Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The acidity of a CH bond is determined by the stability of the carbanion formed after deprotonation, which depends on the electronegativity and polarizability of adjacent heteroatoms, as well as any resonance or inductive stabilization. Moving on to the next step. Identify the acidic hydrogen in each compound. All four compounds have a benzylic CH at position 2 of a 5-membered heterocyclic ring. The acidity of that CH depends on how well the two flanking heteroatoms stabilize the resulting carbanion. Moving on to the next step. A. Two oxygen atoms flank the CH in 1,3-dioxolane. Oxygen is highly electronegative but has low polarizability. It stabilizes the carbanion primarily through induction. B. Two sulfur atoms flank the CH in 1,3-dithiolane. Sulfur is less electronegative than oxygen but is highly polarizable. The larger, more diffuse 3p orbitals of sulfur can better overlap with and stabilize the adjacent carbanion through d-orbital participation and polarizability effects. This makes sulfur a superior stabilizer of carbanions compared to oxygen in this context, as well established in dithiane-dithiolane chemistry, example, Korisibach-Ampolan. Hence the CH in the dithiolane ring is most acidic. C. Two nitrogen atoms, NH, flank the CH. Nitrogen is less electronegative than oxygen and less polarizable than sulfur. Additionally, the nitrogen lone pairs donate electron density into the ring, destabilizing the carbanion. This CH is least acidic. D. One oxygen and one nitrogen flank the CH. This is intermediate, with the nitrogen lone pair donation reducing acidity compared to A and B. And for the final step. Dithiolane, B. Dioxolane, A. Oxazolidine, D. Imidazolidine, C. The compound with two flanking sulfur atoms, option B, has the most acidic hydrogen because sulfur's high polarizability and ability to use d orbitals provides superior stabilization of the resulting carbanion. A. Oxygen is electronegative but poor at stabilizing carbanions via polarizability compared to sulfur. C. Nitrogen lone pairs donate into the system, actually destabilizing a carbanion at C2. D. Mixed O-N flanking gives intermediate acidity, still less than to sulfurs. Therefore, the correct answer is B. Therefore, the correct answer is option B.